This is for Gav. I hope he's still available. Yes, there he is. Okay. Is it okay if I call you Gav?
Yeah, please do.
Cool. Okay, I've got 3 questions, if that's okay. Can I ask them all at the same time?
Yeah.
Okay, the first one is, and this is more of a basic, just for the general consumer out there, who has no background in the way you have it. The 50 hertz that you speak about, that the system has to be kept up, and you spoke about that there's a demand and supply. Could you please explain that a little further so that the ordinary consumer can understand that 50 hertz marker you spoke about? There were a lot of, the second question is, there were a lot of, for the renewable energy suppliers, in yesterday's talk, there was a lot of discussion around how if they would just let, it kind of, if all the politics and all the legislation could just be loosened a bit, this would really solve a huge problem. If you could please give your position on that now with regards to, because you, I think, can give a counterpoint to that, and maybe explain more how it fits within the policies, etc. And then the third question is the maintenance issue, which is traditionally, I know Rula spoke about a great deal more, but which is traditionally brought up as one of the biggest issues around why load shedding is needed. It didn't seem that it was addressed in your presentation. How big is that maintenance issue? And do you believe it can be overcome, or is another solution needed, be it you speaking within your own capacity or as a representative of Eskom? Those are my 3 questions. Thank you.
Okay, Gav, would you like to respond to those?
Yeah, thanks for the questions. Let me tackle them one at a time. So we'll start with the easy one. It's the supply-demand balance. Right, so as I said, the generators run at around about 3,000 RPM, all right, which when they generate at that speed, it gives us our 50 hertz. As we start to load up the network, in other words, more customers connect onto the network and demand more power. So, for example, when you put your kettle on, or if you open the fridge for your favorite beverage, that then adds demand onto the grid. As that demand is added to the grid, if we don't increase the amount that's being generated at that exact moment in time, what happens is the generators start to slow down. And this is now everybody. I mean, we're running a synchronous system, meaning everybody's running at the same speed. If we don't take action and generate more at that moment in time, the speed slows down, and that's the frequency. So you will see the frequency drop. Roughly speaking, our frequency drops by about 0.1 hertz for every 150 megawatts that of demand that comes onto the system. So again, using Lesotho as the benchmark, if we had to switch off the entire Lesotho instantaneously, our frequency would go up by 0.1 hertz, or if we had to switch it on or instantaneously, it would go down by 0.1 hertz. So for practical purposes, the frequency is our speedometer, and it's up to us then to keep it at 50 hertz. The renewables is a fascinating question. You saw some of the statistics that I showed. And I think I'm going to give a personal view here rather than an Eskom view. We've got a very comprehensive IRP, integrated resource plan, sent out by the DMRE. That resource plan obviously calls for a lot of renewables. I think that renewables, it's a no-brainer. I mean, they're the cheapest, they're the cleanest, and they're the quickest to build. So I think that debate around what types of technologies, should it be coal, should it be nuke, should it be this, should it be that? I think that debate is over. I think everybody is very clear the bulk of it will be renewables. I just come from a technical point of view with a bit of a warning. And it's what we're starting to see a lot in Europe and to a lesser extent in America at the moment. You may not know, or you may know that Europe has had pretty low wind yields this last winter of theirs coming into summer. And they've now had to ramp up some of their old conventional plant. Now, that brings with it a bit of a problem for South Africa. we've got a different type of urgency here, where we have old generators. We're going to be retiring them. Yes, we're retiring them for environmental reasons, but also they come to end of life. And the question then comes in, what do we do for the 1 in 10 year events where the wind doesn't blow and the sun doesn't shine? And what do we do for the 1 in 50 year events? I think there's still a lot of engineering that needs to be done. There are a lot of technical problems that need to be solved. We are collaborating extensively with international bodies and our peer system operators around the world. There are some very big problems that need to be solved to maintain stability. A lot of our colleagues have already solved some of those problems where they are a little bit ahead of us in installing renewables. I think the caution here is it's not all plain sailing. There is going to be a lot of work, and there is going to be money that needs to be invested for us to be able to run with a very, very high penetration of renewable. The maintenance question, look, the generation fleet, with the exception of Medupi and Kusile, the generation fleet is got an average age of over 40 years. Now, that in itself is not a problem. An old generator, and if you took a power station like Grootfontein as an example, built in about 1967, still generating, it's a good little power station. So old doesn't necessarily mean bad. I think where we've slipped up as Eskom, and for a number of reasons, Rula was highlighting some of them, but for a number of reasons, we have not done midlife refurbishment. These generators have had an extremely hard life, and we simply haven't done enough maintenance. Maintenance is the main issue here. I think that further than or more than maintenance is a bit of refurbishment as well. It's not just a case of going in and doing the routine stuff. There's replacements that are needed. And I think as we go further as Eskom, and these are the plans that we're busy with now, and the debates that are going on internally, is how long can we run these generators for before it becomes not economically viable anymore? And there's also a healthy amount of environmental concerns in that debate as well. I hope that answers your question.
Yes, it does. Thank you so much. Oh, sorry, I just wanted to know, in terms of the routine, are you basically saying that it's just not a solvable problem at this point? Because I asked you if there was a time space, because that's what everybody, the public, understands it as a maintenance issue. That's the only thing you didn't answer, is if it's actually possible to work with that, to actually get it done.
Yeah, so I can very confidently say these power stations can run. Again, I gave some of the examples of our older power stations. Old is not necessarily bad. The problem that we're having is the money. It costs a significant amount of money to do, major overhauls and refurbishment, and it's the time. We're getting ourselves into the situation where we are really not being able to make enough time to do decent maintenance. We deferred for how many years we deferred maintenance. Thank goodness we are now, biting the bullet and doing the maintenance. But can we bring these plants back? Yes, we can. Will we be able to run them for much longer because of environmental constraints? I think that question still needs to be answered appropriately.
Can I add a metaphor to the old?
Yes.
Medical aid expenses of a 30-year-old and medical aid expenses of a 80-year-old is very different. So I think that's how I understand maintenance expenses of power plants, and that's why I'm saying to myself, yes, they can both run, but definitely the medical aid expenses and the time that they need to maintain, or the time they need to rest after a job, is a very different experience and exercise. So I think that's what we need to start thinking a little bit. And yes, they can run, but I'm wondering how many also of them they need to be replaced in the future with the environmental concerns that Gav is very, very correctly thinking. And it's not something that we can, that Eskom or as a country we can replace from one day to another. And that's the other thing with energy planning. It's not a decision that based on climate change commitments can be made from one day to another. That's something we have to start planning now for the 50 years to come.
Right, thank you, Rula. Thank you, Gav, for your answers. Someone had their hand up, but the hand is now down. Do you still want to ask a question?
There are Q&As in the Q&A section at the
Yes.
bottom, Yanti, here.
I know, someone had their hand up. I just wanted to check about that. Okay, all right. So anonymous attendee said, what causes the changes in frequency? How does available capacity translate into hertz? This may require a science lesson, but I think, Gav, that you've given the science lesson. Is there anything you want to add to that?
No, I think, as I say, you can work as a rule of thumb about 150 megawatts per 0.1 hertz. But
Okay.
the principle really is if the system has got more customers than generation, frequency goes down. We've got more generation than customers, frequency goes up.
Okay, thank you. Then Mike Barker asks, grid interactive efficient buildings can shift shape and shed their load. Does RSA need more demand response? How do we kickstart a market for energy flexibility?
I think, as I said, I think one of the leading power companies in the world in terms of demand response. We've been forced into it. Sometimes that creates innovation. Do we need more demand response? Yes, we do. We have a whole toolbox of products that span different times, different conditions. Some of them automatic, some of them scheduled, some of them dispatched. We do, and as we go into a future of renewables where we have these variations, we're definitely going to need it. The other thing, which I mentioned right in the beginning, we're unbundling this industry eventually in South Africa. We're one of the last in the world to do it. We are hoping, and there's some debate around this, but we are hoping to bring about a market in the near future. And when we start talking demand response, we start talking smart buildings, we start talking the ability to react to price signals, aggregators. These are all the exciting things that could come in the future. We need is the market to unlock.
That is very interesting. Does the green energy building regulations help at all? Do you know?
At this point, I can't really say if that's had an impact at a national level. I haven't really noticed that.
I was quite interested that the consumer response to load shedding actually has any effect. I've always thought that we're just being told to do something so that we feel like it's our own fault that load shedding is happening. But you say there actually is a factor there.
Most definitely, and maybe because we're supposed to be invisible as a system operator, and when you turn on a tap, you don't want to think about Rand Water or whoever, and you don't want to think about a system operator when you turn on your light, and that's the way it should be. We should be invisible. So most of the time, nobody's actually aware how tight we're running the grid, and when we do put out those power alerts, how often those have actually allowed us to avoid load shedding. So it is critically important when we send out those messages that people do respond. It does make it.
Okay, thank you. Right, so there you heard it, everyone. You do need to turn off your lights and your big power appliances so that the system will be less constrained. Carl Kies asked, sorry, I missed that. What is the cost per kilowatt per hour for OCGT, open cycle generators?
So I did mention the number of 3,250 Rand per megawatt hour. So I guess that's 3 Rand 25 per kilowatt hour. It does vary, and I must admit that the price difference between the Eskom OCGTs and the independently owned OCGTs is very similar. But it depends very much on the diesel price. That's the biggest component of the cost. It also depends on the number of startups, shutdowns, the variable maintenance. So there are some variations in that. But as a good rule of thumb, you can work on about 3,200 to 3,250 Rand per megawatt hour.
Okay, thanks so much. Then Suresh Babu Naidu Krishna says, what about load shedding that is not anticipated, like today in Berea? I think you've dealt with it.
Yeah, look, Suresh, I think we always have these problems, and I don't know whether it is a network problem. It's really difficult. Sometimes we have network failures at a local level. It might be at the municipal level. It might be at the distribution in-feed level. It's very difficult to say. It could be just a network problem, or it could be that somebody is not following a schedule in the municipality. My best guess, without knowing the details, would be the former.
Right.
Can I chip in here without knowing the specific problem? I think it's a public awareness problem as well, and the definitions of what is a load shedding and what is a maintenance problem and what is a power cut and what is a I think it's a to the ground problem. And also we had these issues of what is a load shedding and what is a load reduction that also created quite a lot of problems. And I think we need quite a lot of work with the communities to understand what is the difference, and a lot of work with the communities to understand. Like, I think both our presentations were quite straightforward with that the load shedding is a solution to the crisis and not the villain. Load shedding is not the villain. Load shedding is actually what we do to prevent the bad situation from happening. So I think there's quite a lot of work to be done with creating awareness.
Right, thank you. What is the difference between load shedding and load reduction?
All right, Yanzi, that's a good question, and it is laid out very clearly in that NRS 048-9 document. Load reduction is actually a term for load shedding and load curtailment. So now I'm introducing another term of load curtailment. Without going into detail, load curtailment is a method of getting rid of load off the network. It has very specific requirements, and it's typically only done by very large energy-intensive users who can manage their own plant. So we'll give an instruction and they will reduce the portion of their plant. The big difference here is while load shedding blocks are rotated, load curtailment is not. It's off permanently, so for the duration of the crisis.
Okay. Thank you for that. And then I've got a question related to what about load shedding, which is not anticipated. We had our NSTF South 32 awards on the 30th of September. And the moment we were about to start, we had a power failure. In that time between the power failure and the generator kicking in, all the AV settings on which we were relying went out. And so it was a huge fiasco. It was just at the area in which the Houghton Hotel is in Johannesburg. So that is the kind of thing that happens when you're not anticipating any load shedding. But I think you've answered that.
Yeah, I think maybe just to add, you know, when we shed, it's painful for everyone. We don't have from a national control center point of view, we don't have the visualization all the way down to that level. And this is why we ask the distribution guys to shed for us. You know, they are not operating the lower voltage networks where they can actually switch suburbs and possibly blocks, you know. Whereas at the level that we're operating, if we open breakers where we are, you would take out an entire city or an entire town. And I think there are opportunities, and I know it's sometimes really difficult to get into Eskom, but the call centers are the first port of call, where if we do have, for example, an international rugby match, for example, where we have a sitting of parliament that's quite critical, we have been approached and we've been able to just remove that portion of the block from load shedding for a specific amount of time. Again, NRS 048 is very clear on what can and cannot be done. So it's not just a free for all, it must be in the national interest. But I'll mention that just as one of the possibilities. Please don't flood us with inquiries on taking off the load shedding schedule. Clearly, if we want to avoid a blackout, everybody has to play their role.
Okay. Noted. Then a question from Mike Barker. Australia has identified a lack of DER standards as an issue as more distributed inverter loads are connected to the grid. Who will drive the adoption of standards like IEEE 1547 in RSA?
I guess that one's aimed at me as well.
I'm afraid so.
Yeah, so I can't speak to that particular standard, but what we have done, we were quite progressive at the time because we could learn from people who have already had experience with renewables and with inverter-based generators. We wrote a grid code, which was called at the time the Renewable Code, and subsequently has been moved into the main grid code. That has now just undergone another review as well. And that grid code sets out, to a large extent, those standards. I would not be surprised, but I can't speak for certain whether that standard has been incorporated. But we certainly have had a lot of international input and reviews into that. We've also just recently finished the battery code, which is also obviously for inverter connected plant. So those are incorporated